Hello everyone, I'm Jiayi Hu from the University of Tokyo. Today I will present our work titled Relocation of Body Ownership between Avatar and the Omission Entity in Third-Person Perspective VR. Let's start with the background. In recent years, third-person perspective VR have attracted increasingly interest as a novel interaction paradigm. Most prior research focused on viewpoints coupled to the avatar, either fixed or following. In contrast, we investigate in hierarchical structures, where users operate from an omission entity or OE viewpoint, a detached free-flying perspective capable of independent movement and environmental intervention. These structures introduce an unique feature: two distinct asymmetric entities, the avatar and the omission entity, coexist in the same scene. Users may potentially embody either one. Here is an example inspired by commercial 3PP VR games such as Mouse. Users control the avatar while also interacting with the environment from a high-level perspective. This raises an important cognitive question: when two controllable entities coexist, which entity do users perceive as self? We focus on the sense of body ownership, or SOBO, the reflective feelings that a body belongs to oneself. We therefore ask, first, does SOBO dynamically switch between avatar and OE? Second, at the macro level, how do design factors influence this allocation? Third, at micro level, how do user behaviors affect ownership within the same experience? Based on the research questions, we then introduced experiments. We manipulated involvement levels. In the maze phase, avatar involvement was low, and OE involvement varied across low, medium, and high. In the battle phase, avatar involvement was high. This allows us to examine how themes design biases ownership allocation. We also recorded behavioral indices. For visual attention, we analyzed gaze angle. For control intensity, we extracted joystick inputs, attack actions, and trigger interactions. Participants continuously rated their SOBO retrospectively while watching recordings. We collected gaze and control time series data and conducted semi-structured interviews. 21 participants completed the study, with a mean age of 27.4 years. Each participant first completed a short practice session. They then experienced 3 maze battle sequences. After each maze battle sequences, participants provide retrospective continuous SOBO rating while watching the replay. Finally, we conducted a semi-structured interview to capture qualitative insights. We used non-parametric Wilcoxon tests with FDR correlation for condition comparisons. Behavioral predictions were performed using linear mixed effects models. Interview data was analyzed using a reflexive thematic analysis. Then we introduce the result and the discussion. The figure shows averaged SOBO time series. SOBO is not statically shared between avatar and OE. Instead, it shifts systematically at scene transition from maze to battle. Ownership relocates rather than coexists equally. In the maze, OE ownership increased stepwise from low to high involvement. In contrast, during battle, avatar ownership is consistently higher than in all maze conditions. This indicates that scene design systematically steers ownership allocation. Behavioral indices further moderate allocation. Gaze angle shows a crossover pattern. Looking towards an entity increases ownership towards it. Active control strengthens ownership of the controlled entity. Importantly, behavioral effects are stronger in the maze than the battle, stressing greater reliance on the real-time interactions under uncertainty. Interview reveals three themes. First, attention acts as a gatekeeper. Ownership shifts towards the entity aligned with virtual attention. Second, attention effect contingency strengthens ownership. Third, task structure biases allocation. While salient events triggered rapidly relocation, these qualitative insights converged with our quantitative findings. Finally, let's introduce the conclusion part. This study has several limitations. The sample size was relatively small, and the experiment order was fixed, which limits the generalizability. In addition, retrospective ranting method may introduce reconstruction bias. In future work, we plan to employ counterbalanced designs and integrate physical-logical measures. We are aimed to translate the switching principle into adaptive 3PPVR systems. In conclusion, SOBO functions not as a static property, but a fluid resource dynamically relocated between two asymmetric entities. Allocation follows design factors at a macro level, and moment-to-moment gaze and control intensity predict ownership at a micro level. Together, these findings provide a structured account of how body ownership relocates in hierarchical 3PPVR. Thank you for the listening.